Hi guys, it's me, Mr. Bertoch. In this video, we're going to talk about atmospheric currents, oceanic currents, gyres, and subtropic highs. In the oceans, in the ocean basins, and when I say oceans, they're all interconnected. You knew that, right? They're all touching each other. They're basically one big, ginormous ocean. But we divide them up as different oceans based on ocean basins, where there is like a lot of water together, separated by at least some land. In these oceans, there are currents. They're like rivers moving water from one place to another. In the atmosphere, there are also moving currents of not water, but well, there is water, I guess. There's gas, water, gaseous water. Anyway, but air, there's air currents. What is causing the water in the ocean to move, and what is causing the air in the atmosphere to move? And the answer is very similar things, very similar processes. And in this video, your goal is to understand by the end of this video what causes oceanic currents and what causes atmospheric currents. So we're going to start with oceanic currents first. In each ocean basin, it's very common, it happens all the time, that I get high pressures that form in the tropics, in the subtropics, and we call these subtropic highs, and they are massive, and they pretty much fill up the entire oceanic basin. These subtropic highs form in each ocean basin. And around these subtropic highs, the water is pushing outward, but because of the Coriolis effect, and I talk about the Coriolis effect in another video as well, I'm not going to go into it in this video in any depth, but just know that it makes the water curve. Because of the Coriolis effect and these subtropic highs, the water begins to spin around, outward, away from the subtropic high. In the northern hemisphere, it spins clockwise. And in the southern hemisphere, it spins counterclockwise. Now, I should note that lows, which is bad weather like hurricanes, they spin the other direction. So in the northern hemisphere, they will spin counterclockwise. And southern hemisphere, they'll spin clockwise. But we're talking about highs. So high pressure in the northern hemisphere, they spin clockwise. So in each ocean basin around this subtropic high, because in the tropics, the water is really warm, so it forms a high pressure and it pushes outward, then the ocean begins to spin, and we call that, incidentally, a gyre. Hooray for gyres. And gyrate. You've heard gyrate. It means like rotate. It means like shake your hips. Gyrate. Okay, that's the gyration is to spin, and that's what's happening in the ocean. So we call it a gyre. So these gyres form. Every oceanic basin pretty much forms a gyre. Well, notice that the water in the ocean is, because it's spinning, it's creating currents. So for example, along the eastern coast of all continents, the water tends to go from the equator. It moves from the equator up towards the poles. And along the western coast of continents, the water tends to move from the poles down towards the equator. So I get these rivers of water that are moving along the edges of the continents. And on the eastern side of the continents, the water is moving from equator to pole. And on the western side of continents, it's moving from pole to equator. And the result of that is the water on the eastern side of continents tends to be warmer, and the water on the western side of continents tends to be much colder. So that is why at the same latitude, it's warmer in South Carolina than it is at the same latitude on the western United States. The water in the Pacific Ocean along the western United States is much colder than it is along the eastern United States at the same latitude. So those are oceanic currents. There are other oceanic currents as well. One very significant one is the thermohaline circulation, which is, I'm not going to talk about in this video, but it's a massive current that goes all over the world. And there are many, many currents around the ocean. So, dear half-size humans, what is causing atmospheric currents? Well, it's a very similar thing, except that the air is able to go over the surface of the land. So in the atmosphere, I have the same thing. I have subtropic highs that are forming over the tropics, and these subtropic highs are causing the air to rotate. Remember, in the northern hemisphere, what direction does it go? These are high pressures, not low pressure. So high pressures in the northern hemisphere rotate clockwise and counterclockwise in the southern hemisphere. Right below a subtropic high, I am going to get the wind that is going to come from the east towards the west. And we call that a trade wind, but we also call it an easterly. So in the northern hemisphere, we often refer to it as a northeast trade wind. Winds got their names a long time ago, before we really understood all the phenomena that caused the wind. They were named often by sailors. And sailors weren't looking at the wind from the top down like we tend to do on a map. Sailors were looking at the wind from the direction it was coming from. So a wind coming from the east towards the west, they would call it an east wind, because they would say that wind is coming from the east. So an easterly, an east wind, comes from the east towards the west. It's named based on where it comes from, because that's how it made sense to sailors to name them. It's not named for where the wind is going. It's named from whence it comes. So right below a subtropic high, because the wind is going in the northern hemisphere, it's going clockwise. That's going to make the wind come from the east and blow towards the west in a kind of an arc because of the Coriolis effect. And again, I talk about the Coriolis effect in a lot more detail in another video, but it makes things curve. So I get an easterly. Right in the subtropic high, like right where it's at, I'm not really going to have a lot of wind. And we call that a doldrum. A doldrum is a place where there isn't a lot of wind. And if you're not careful as a sailor, you can get stuck there for a while until you get a storm to carry you through. Right above a subtropic high, I'm going to get a wind because it's still going clockwise, but now I'm above it. So it's going to go from the west towards the east. Well, what are we going to call that? Remember, winds are named from whence they come. So if it's coming from the west and going to the east, it is going to be called a westerly, right? And then right above that, I get another little area of doldrums where there's not a lot of wind on average. I'm not talking about storms, because storms come through and they mess everything up. But if there are no storms, these are how the bands of wind tend to blow. And then right above that doldrum, I'm going to get another easterly called a polar easterly. And it's caused by a region of high pressure on the top of the earth, or the top and bottom, the poles. Okay, and the same happens going from the equator southward. I'm going to get a southeast trade wind, which is an easterly. I'm going to get a subtropical high where there's a doldrum. I'm going to get a westerly, which is right above or right below the subtropic high in the southern hemisphere. And it's a westerly now because the wind is going the other direction. It's going counterclockwise. And then I'm going to get another doldrum, and then I'm going to get another zone of polar easterlies. Because there is no land to corral the winds in like there is with the water, I don't get the gyres that start to form. It doesn't spin around the continents. It just simply creates bands that travel around and around and around the earth. So the atmospheric currents tend to travel in bands. The oceanic currents tend to travel in gyres that are corralled in by the coasts of continents. And the atmospheric currents tend to carry weather and storms in them. High pressures and low pressures tend to move along with these atmospheric currents. The oceanic currents carry warm water and affect climate, creating warmer climate on the eastern coasts of continents and cooler climates along the western coast of continents. So atmospheric currents tend to affect more weather, and oceanic currents tend to affect more the climate. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.